Recording, go.
So let me just start my own and share the screen. Okay. Do you see my screen? Hope so.
Yeah, can you change the resolution? Yeah, this is better.
So yeah, I've zoomed in a little so everyone can see. I'm gonna assume nobody knows what I'm talking about, so I'm gonna go a bit into detail about what exactly are our system tests and how they work. So what they are basically Python scripts, which you can see do something. Then they test, well, they test the system. They test how Lucid behaves in certain scenarios. And instead of doing everything by hand, you write a script in a more general sense, and it does everything for you. As you can see, you create nodes, you initialize file systems, you link, you write, you sync, you do stuff which you can basically do by hand, but this automates everything for you. So for every script, we also have a result, which is basically what we expect to happen when we run this. So how it works, most of the legwork is done by, well, let me find it. Yeah, most of the work is done here. This is a command in Python that allows you to run an arbitrary string as a Python file. So for every script, the process goes through here and executes it as a part of itself. There are a few problems that with the current architecture don't allow us to run multiple tests in parallel. Mainly that this command, the exec command, the first thing is the script, as you can see. The second command is a dictionary. And for those of you that don't know what a dictionary is, it's basically this. It's a key value store. So you have a key with the name and it has a value. The value can be anything. It can be an integer. It can be a memory address. It can be a function call. It's up to you. So as you can see here, we are using a globals dictionary, which is by default in Python is the global dictionary for everything running in the current interpreter. So you can imagine how this can be a problem if you want to run multiple instances, but you want this to be different in each instance. If it's global, you can't do this because for another test, if you use this, it will address the same object, but you want the underlying object you address to be different for each test. So this is something that, well, this was the root of the problem. So how I solved it, I didn't really. In Python 3, what Python 3 allows you to do is point it to your own dictionary, which I've defined as something that's root for each test director, and we start a test director for each test, as you can see here. For each test, we open another process. Yeah, so basically, this is what the system test is and how it works. I try to keep this brief. So this is my proposed proof of concept. It's really basic for now. And you can see it also logs some stuff. So there are a couple of commands. And you can also, you can point it to a directory or a file, specific file, and it's gonna run it as a system test. I'm gonna start also a process here, which is gonna monitor for processes that contain Lucid in their name, just so you can see that we're gonna have multiple ones running simultaneously. So here, I'm gonna try to run a single test, which you can see here. It's really basic. We start the node, we log something, we sleep for 10 seconds, we log again, then also test print, just why not? And as you can see, it started, it says it's gonna go to sleep. You can see the instances we are using here. Then after 10 seconds, it's going to print again from the logger. Then it's gonna print to std out, which we capture so we can compare the result. As you can see, here is the test print from this. Well, this is the default logging configuration, which is really basic by design, because I didn't want to spam everything with unneeded information. But if you run it in verbose mode, it's going to be a bit more specific about what exactly is happening internally, just so it's easier to debug. So I showed it with a single test, and it's obviously working because we finished with a result true. Basically, this means that the output for this test is the same as what we were expecting. Whoops, sorry. So I have a couple of tests, 3 to be more specific. As you can see, in each of them, we have a 10-second sleep. What I'm gonna try and prove with this is that running the 3 is gonna be simultaneous, because instead of sleeping for at least 30 seconds total, we're gonna sleep for 10 seconds, at least 10 seconds total. So all of these are in the same directory. I'm now gonna attempt to run it, and let's just clear the log. And so you can see we start the hub, we start the processes. Oh, I didn't focus here. And we log for everything that's happening. Also, we are timing the command, and you can see it completed the 3 tests in 12 seconds, which if they were running not concurrently was not gonna happen, but because they are running concurrently, it's just faster. So basically, this addresses the issue we have right now, which is that we have a lot of tests and we can't run them at the same time. So you can see we have about 30 tests here. Some are even disabled, so there's even more. And this list is only gonna grow, and it's gonna get worse from here on out. So the sooner we can do this, the easier it's going to be to address this underlying issue. So yeah, there's a lot of work still to be done. As you can see, the tests are really basic. There's almost no functionality for now, but the underlying architecture is in place, and and it's working. So yeah,
What do you
that's
think
pretty much it for me.
to be able to run our system tests, not the sample code that you've written here, but the real system tests?
Well, that's the end goal, but for now, I tried to do it for the demo to add some of the functionality that's required. For example, for this script, it's really basic. You can see in it we link some basic stuff, but I just couldn't finish it in time.
No, I mean, what have you identified in terms of remaining work?
Well, most of the actual functionality.
Okay, so a lot of work still.
Yeah,
Okay.
a lot of work to be done, but it's a start.
Okay, fantastic. Let me just say a couple of words, kind of high level, why we're doing this, right? So the build today is comprised of multiple steps, most of which have been parallelized by now. So first of all, the actual build of the product is highly parallel. Then we're running a set of unit tests, which we also parallelized over time. Then we have a bunch of Python tests, which are not parallel, but they don't take a lot of time. And then we have this long list of system tests, which today are run one after another. And so the bulk of the total build time is taken up by running the system tests. And that's a huge drain on the productivity, because every time I need to test something, I have to run the full build, which includes running the system test. So this can give us a tremendous productivity boost when we do that. So this is very valuable internally for development. Just wanted to, you know, put things in perspective.
Yes.
Thank you, Max. That was great.
Yeah.
All right.